All right, welcome back. Let's take a look at one of the question requested by one of my students. All right, now this is questions related to vector in three-dimensional space. Right? Now we have 2 points A and B have that position vectors given by these two vectors here. Now the line L has an equations given by this. Now we need to show that the line L does not intersect the line passing through A and B. Okay. Now before we start with this, let me show you the how does this all this object actually look like in the three-dimensional space before we start proving that the line L does not intersect with AB. All right. Okay. So here you can see that. Okay. Um, Now basically we have two lines here. There is one line that has been given by this equation here, which is purple in color. And then the line that passes through AB is given by that red line. Now, at a brief glance here, you can see that as if the line that passes through AB actually intersect the line that is represented by this equation here. Right? Let's take a look closer to see whether that is true or not. Okay, so here I'm going to rotate a bit. Now you can see that if you rotate further, you will notice that, all right, now from this point onward, it may look like they are actually intersecting between the purple line and the line that passes through a point AB. But if you look closely, or if you look closer, if you turn and look at it from another perspective, for instance, they are actually not intersecting. Right? Now that is our visual representations of the line represented by that equation and the line that passes through AB. Okay, how are we going to prove that they are not actually intersecting? Okay, this is how we are going to do it. Now, first step, we're going to work out the line equation that represent the line that passes through A and B. Okay, so first of all, we need the directions for the line that passes through AB, which is this line here. Let's call this line L2 then, right? So the direction is given by AB, so let's call this AB then. Okay, let's work out the vector AB. Now AB will be given by 4, 1, 1 with OA. So OA is given by 2, 1, 3 here. Okay, so let's see what we have here. We have 2, 0, negative 2. Okay, and then there you have it. This vector, relative vector AB, would be used as directions for this line L2 here. Now, therefore, the line equation that represent L2, here I just write down L2 here. The vector equations to represent line L2 is given by, let me call this as R2 then, for instance. Now we need a point that passes through that line L2. Now here you can see that you can either choose A or B. Doesn't matter which one you use. Now let's use A then. Okay, so A, which is 3. And then we need a parameter. In this case, we call it parameter. Like for this line L, it has a parameter mu here. So maybe we can represent the parameter for line L2 as lambda. And then following by its direction. So the directions can be given by this. Okay, and then there you have it. That's the line equations that represent the line passes through the 2 points A and B. Okay, there you have it. You can also write this line equation in a more compact form. For instance, you can write like this. In this case, it's just 1. 3 minus 2 lambda. Okay. Now as for line 1, okay, so line 1 we have the equations. So in this case, I just rewrite that notations differently. So line 1 is 4, 6, and 0. Okay. Plus the parameter, which is mu, 1, 2, and negative 2 here. Okay. We can also write this in a compact form, which is 4 plus mu, 4 plus mu, and then you have 6 plus 2 mu here. And then after that, we have negative 2 mu. Okay. Right. Now, there you have it. We make assumptions that they would be meeting. So let's assume that they do meet, assuming that we don't know where these lines are in the three-dimensional space. We assume that they do meet, so we make assumptions. We assume that L2 and L1 meet. So we assume L1 and L2 would be meeting or intersecting. Okay, sorry about that. There's a delay in my writing here. All right, so we assume that L1 and L2 intersect. So therefore, if we make that assumptions, all we need to do is just solve this equation 1 and equation 2 here. And then if they do meet, therefore we should have a unique solutions for our parameters lambda and mu here. Now that's what we hope to get, right? Okay, now before that, let me minimize that. Okay, let me erase this off. Now all you need to do is just solve this. By solving this, we just need to compare each row elements. So therefore we have this 2 plus 2 lambda must be the same as 4 plus mu. So from here we can easily form an equation, for instance, which is actually equal to 2. That will be our equation A, for instance. Okay, maybe I don't want to represent A, represent it as equation number 3. And then next we can compare the next row. 6 plus 2 mu is equal to 1. Now therefore in this case we can easily discover the parameter mu actually represent 2.5. Okay. Now knowing that mu is 2.5, then therefore the lambda would be from equation number 3 there. We would be able to get 4.5. So that will be 2.25. Okay. Now we have successfully obtained the mu and lambda, and then we may thought that yes, they do intersect, but don't forget you do need to check the last row to verify whether this lambda and mu are unique. If these solutions for lambda and mu is unique, then yes, we can confirm that the two lines do meet at a unique position. Okay, so let's try to work out the last row. Okay, so the last row suggests that. Okay, now this part I'm going to write down at the side here. The last row usually meant for checking. Okay, so for checking, we have 3 minus 2 lambda equal to this. All right. Now all we need to do is just check this through. All we need to do is, if I rearrange this properly, or I can just substitute this value here. So my left hand side, for instance, which is 3 minus 2 lambda, that would actually give me 3 minus my lambda is 2.25. Okay, so 2.25, that is basically like 4.5. So I get negative 1.5 there. Okay, and then on my right hand side, I can also check that just by substitute my mu equal to 2.5. So my right hand side would yield a negative 5.0 there. Then you can see that this is definitely not the same as the numerical values that we have obtained from our left hand side expression. Therefore, we can conclude that no unique solution for lambda and mu. And then what does that mean in this case? It means that L1, L1 and L2 does not intersect. Okay, now we have successfully proven that L1 does not intersect with the line that passes through A and B. Now the method that I'm using is called the proving by contradiction, right? If you're interested to learn more about the proving method, right? I hope that is clear for this uh, section here. We're going to move on to the second section shortly. All right, let's take a look at the second section of this question here. We have a point P based on this diagram here. You can see that we have a point P with a parameter T. So this parameter basically refer to this mu here. A line is on the line L and it's such that angle PAB is equal to 120. So angle PAB that is creating a 120 degree, right? So here we just need to check that there is such point that is lying on line L in this case, where it will produce an angle of PAB equal to 120. And then therefore, if that is the case, we have to prove that it will form these quadratic equations with the parameter t. And then thereafter, we just need to solve that quadratic equations, and then hence we should be able to obtain the specific positions vector for P. Now let me show you how would it look like in three-dimensional space here. Okay, all right, now you can see the short animation. So we have a point P. The P can be any position on the line L, whereby it will create a perfect angle of 120 degree at a specific position highlighted in this diagram here, P. Right now, that positions is the one that we are going to obtain by uh, solving these quadratic equations. But before that, we are going to prove these quadratic equations is true based on the conditions given. Right now, we have that angle 120 here. Right now, all we need to do is now we're going to make use of this um, scalar products formula here. All right, now we're going to make use of the scalar product formula. Let me show you the scalar product formulas that I'm referring to. So that is here. Okay, so we're going to use AB dot with AP in this case is given by AB cos the angle between PAB here. Now, just let me label the angle of PAB as theta for ease of analysis in this case, right? So we're going to make use of this scalar products formula to work out the angle of PAB equal to 120. So in this case, the angle theta here is actually equal to 120 degree. Right? And then we also notice that cos 120 degree is basically negative 0.5. Okay, 0.5. So therefore we can actually work this out. Now before that, we have also worked out AB before this. Okay, now our vector AB, we have already worked out AB before this. So I'm just going to write this one down one more time. Now that will be a 2, 0, and then a negative 2. Now that will be our vector AB. And then next we're going to work out the vector AP. Now we know that the position vector P is lying on this line here. Now this line can be written in its compact form. I hope that you still remember this line can be written in its compact form as 4 plus mu. It can be 6 plus 2 mu, and then finally negative 2 mu here. So it can be written in this compact form. I'm just going to write this one down. So therefore, because this can be written in this compact form, then we say that there is a position vector P somewhere lying on the line L that can be given by this position vector here. But since the point P come with the parameter T, so instead of using mu here, I should be using T instead. Okay, just let me change that using T. So that will be a T, and then I have 6 plus 2T, and then finally I have 2T here. Okay, now next, all I need to do is to work out my AP. So therefore, I need to work out my relative vector AP. Okay, so AP basically is P, this is P minus A. Okay, so my A is somewhere here. I have 2 plus this. I have my 5 plus 2t here. And then finally, I will have negative 2t minus 3. Alright, so there you have it. There's my position vector, relative vector AP. Right, now from here, we are ready to substitute all these value into this equation here. Right. Now therefore, this AB here is given by 2, 0, negative 2. Scalar product with AP. And then the magnitude of AB. So magnitude of AB in this case is basically 2 square plus 0 square plus 2 square also, square root. And then I'm also going to obtain the magnitude for AP, which is 2 plus t square here, plus 5 plus 2t. And then finally, now I'm going to ignore the negative here, because if you square the negative, you will get a positive. So therefore, I just write it down in its simplest form. Okay, and then of course, I need to multiply cosine the angle PAB. So cosine angle PAB is actually negative 0.5 here. Okay, now that is what I'm having at this point of time. Okay, so just let me erase this so that it's not messy. Okay, so I hope that is clear at this point. Okay, now all we need to do is just finish up this algebra. So you can see that from here we have, okay, from here I have 4 plus 2t. Okay, this part is 0, and then next part I will have 4t plus a 6. Okay, so from here I can simplify. That's actually 2 sub 2. So multiply with this is negative sub 2. And then I can expand everything inside the square root there. So let me do that very quickly. 25, 29, 29, that will be 38. Okay, and then I'll have 4, 4, 24, 24, 36T there. And then finally, let me see, 4, 8, 9 T square. Alright, now that's what I have on my left hand side. And then of course, all I need to do is simplify this section here. You will notice that I have like 10 plus 6T here. So I'm going to erase this. I'm going to simplify this a bit. Hold on. So let me simplify that as 10 plus, that will be 10 plus, what do I have already? 6, 8T. Okay, just let me check one more time. That is a 4, 6, 10. Okay, this one is a 4 with 2. Okay, sorry, that's a 6. And 60. All right, so there you have it. Okay, so there's a 4, there's a 2, so therefore 6T. 6 and 4 is 10. Okay, now next, in order to solve this, all I need to do is square both sides. I'm going to apply square both sides. The main reason is because I want to get rid of the square root here. Okay, doing so, I will have like 100, 120t plus 36t square. Now that will be equal to 76, 72, and then finally I have 18t square. And then simplifying both sides, I will get 18t square, and then I will have like what do I have here? 48 t, and then finally I will have 24. And then further simplifications would yield, I can divide both sides by 6, of course. And then therefore, I managed to prove these quadratic equations, which is 3t squared plus 8t plus 4. Right? So therefore, this has been proven. Right? Now, I hope that is clear. Now, the last part would be very straightforward. All I need to do is just solve this quadratic equation. So solving this should not be any problem here. I believe if you solve this, you should get t equal to 0. Just let me check for a while. 6 and 8, yeah, correct. Now, therefore, from here itself, you will find that the t could be both 2 over 3 or negative 2 here. Yeah, it could be either one of these that would actually yield the angle equal to 120. Okay, 120 there. All right. So from here, all you need to do is just substitute this value back into either one of these formula. So the formula that I'm referring to would be the OP would be this, or the OP would be this for the value of t equal to negative 2 over 3 or negative 2 here. Right. So just let me check one more time, because there is only one positions factor, but you have two such a value here. So let me see whether that is possible in this case. So now one of them would definitely yield a 60 degree, because cosine 60 degree is the same as um, negative cosine 120. right? So both of them are actually 0.5 due to the fact that we actually square both sides. So squaring both sides would render the negative become positive in this case. That's the reason why we have both of these position vector here, right? So therefore, never mind. At this point, all we need to do is just substitute this either one of these t back into here. Therefore, we have two position vector for all p. And now I'm going to write it down here. The first one for t equal to, let me use -2 first because it's easier to work with. So for t equal to -2, I would get my position vector for p would be a 2, and then that will be a 2 also, and then finally I'll get a 4 here. Okay, now that will be my position vector, and then for t equal to -2/3, my position vector OP would be all I need to do is just substitute this one here, 12. That will be 10/3, and then that will be 4, 14/3, and then finally I will have 4/3. Okay, just let me quickly check this through in this case. If I put that in, it'll be -4, 18, 14. Okay, that is right. Right. Now I'm going to pause here for a while. We have two possible position vector for P. Now, which one would actually give us that particular position that we yield that angle of PAB? Now, I'm going to verify that. Right, like in the exam, I have no idea uh, which one of these would actually yield that angle 120. But I do know that these two t value does satisfy that quadratic equation, right? Okay. Now, if you're okay, I'm going to clean this up, and then we're going to verify that. Right? Now we are ready to verify which one of these t value would actually satisfy this condition, having an angle PAB equal to 120 here. Now let's start from t equal to -2/3. Right? Okay, for this we have AB here, still the same. The only one that we need to work with is AP. Okay, let's look at AP. By substitute this value here, we will have 4/3, and then what else we have? 11/3, and then after that we will have let me see here, -5/3. All right, so now we are ready. All we need to do is to work out the scalar product for AB and AP. So let me work out the scalar product for AB dot with AP here. Okay, now if you try this out, this is typically 8/3 plus 10/3 here, which will yield 6. Okay, and then next on the right hand side of this equation here, we can try this out, and then let's see what do we have. Cos theta, which is actually equal to a 6 in this case. All right, that is actually a 6. Okay, now before that, yeah, maybe I don't write this one down. AB, so AB we have already found that, which is cert 2, and then AP typically all of them have 1 3, so that will be 4 square plus 11 square plus 5 square. Okay, and then here we have cosine theta, which is equal to a 6 here, right? Now, if you try to simplify this, we will end up with, let me see, what do I end up with? I'll end up with 12. Did I get it right? Just let me check one more time. 18, 18, 6, 12. Yeah, correct. So from here, you would use a 12 cos theta equal to a 6. And then from here, it's quite obvious that the angle is actually equal to 60 degree, which is not the one that we need. So we are going to exclude this because the angle that we are interested to look for is 120 here. Now, anyway, don't get too excited. We still need to verify the for t equal to -2. Okay, just to be sure. Right? Now, the same thing, I'm going to work out my AP here. So for my AP, I will have a 0, that will be a 1, and then that will be a 1 also. So from here, I'm going to work out the numerical value for this scalar product between AB and AP first. Okay, that would actually yield a 0, a -2. Okay, that will actually use a -2. Did I get it right? Just let me check one more time. -2. Yes, correct. It's a -2, right? And then after that, all I need to do is work out the right-hand side expression. And now that will be the magnitude. Okay, so AP cos theta. That will be 2 sec 2. And then AP, okay, AP is here. That's good. Which is actually sec 2 cos theta, which is equal to -2 here. And then that will be typically what do we have here? A 2, a 4, -1/2. So cosine theta equal to -1/2. And then that would yield an angle of 120 degree. Okay. We are only interested in 0 until 360 degree. Okay. So therefore, yes, at this point, we are quite happy with the result. I'm quite happy with the result. We successfully verify that the correct t value that would yield this angle PAB equal to 120. Therefore, we can conclude that the correct position vector for P is given by this position vector here. All right. So I hope that is clear. Hopefully, it will help your learning. All right. Until I see you again, take care, everyone.